equations of these transformations of sine and cosine. The first thing we need to look at is really telling if do we even have a sine graph, a cosine graph, or maybe a reflection of one of those in the x-axis. So we're going to graph each of these graphs using the unit circle. So we know the first thing we have to do is do the points on the unit circle. So I have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. We're not going to do full tables. We're just going to use these to draw our graphs. We know when we do these, one period, if we just do a basic graph, is my 2 pi. So this will be a pi here, and then I have pi over 2 and 3 pi over 2. So if I'm following sine around the unit circle, I'm going 0, we'll put some scales on here, 1, 0, negative 1, 0. That point over a little bit. And if I'm going to do a negative f of theta, I'm talking about a reflection in the x-axis. So this graph, if I did negative sine of theta, we'll just put a little bit of information down so you can see it. That y-intercept would stay the same. This point, and my scales are not super even, so I'm going to move this over just a little bit. We'll go down, up again, and down. So this graph, when I see this type of shape in the opposite direction, starting off in the opposite direction, that's going to be negative sine of theta. So as I graph my cosine graphs, I am going to be following the x values around the unit circle. So similar scales, we'll just get those on. So cosine, x value starts at 1, then goes to 0, and negative 1, 0, and 1. And we'll start to look at properties, like what are we looking for as we do these transformations. So if I reflect cosine in the x-axis, instead of starting up at the top, I'm going to start at the bottom, because that's where the reflection would go. Then I come up and back down. So the graph would look like this. So we're going to look at those 4 graphs and start to say, okay, if this was transformed, because if this is transformed, my graph might not still start on the y-axis if I shift it up, or my graph might not be at 1, right? It might be at a different number if I change the amplitude. So how do we generalize and say what's kind of always the same on these graphs? So we're going to look at our 2 sine graphs first. Now, our y-intercept right here, we might be tempted to write that that's always 0, but imagine if we shifted the graph up, it would no longer be at 0, even though it was a sine curve. So the key is that the y-intercept of every sine curve is in the middle of the max and min, which we know is where the midline is. So we're going to write on the midline. So where do we go from there? We're starting in the middle, and we have to decide, do we go up or down? If we have a positive sine curve from the midline, the graph first increases or goes up. And if I do a negative sine curve, the graph first goes down or decreases. So we're looking for a graph that starts on the midline for sine, and then positive sine up, negative sine down from there. Looking at my 2 cosine graphs, it might be tempting to say that the y-intercept of a positive cosine curve is 1, but either with a shift up or even a vertical stretch, right, that number is going to move. So where does a positive cosine curve start? Right, it starts at the maximum. Right? At the max. So even if we stretch it or move it, we're just looking for it to start at the highest point. From there, if I start at the max, the only place I can go is down, right? So from that point, the positive cosine curve has to decrease. So looking at my negative cosine curve, hopefully not as tempting to say it starts at negative 1. we can say it starts at the minimum or the lowest point. And if I start at my lowest point, I have to go up. That's the only place, even I'm saying, right, you can only go up from here, right? If you start at the lowest place, the only place you can go is up, or it increases. So we're going to use these patterns as we start to look at the graphs.